respond to
All right.
viewer comments. It's very exciting.
Weird.
It's easier than I thought it would be. Like the crowds. That's a threat. Because you're like, oh, now I feel like perspective.
All right, everybody, grab a seat. Get started. All right, so Mike's gonna lead the way. We're gonna do joins and work with times and dates today. So we're gonna do a little bit of both. Doing tidying, which is like moving data from long to wide and wide to long, reshaping the data, and then joining different tables, which is super powerful and really, I think, one of the cooler things you can do in R really easily. Not really easily, back that up, but you can do it in R. And then times and dates, and we'll have a challenge at the end. So take it away.
Does everybody have sticky notes?
Oh, yeah.
All right, we'll get those.
Yeah.
So go ahead and open up this website here. Go to week 8. That'll get you to the lectures tab. And go to week 8. Pull up the Google Doc, this document, and then just like the past few weeks, add 1 point about the homework that you liked, that you thought you understood well. And then what your sort of muddiest point, the sticking point for the homework too. There's Adam right there for the Google Doc. Take about 5 minutes to do that.
Oh yeah, I had that.
And then green sticky note up when you're finished. You finished.
Okay, got it.
I know, I see what someone else is. No, I think
All right, noted. Noted.
Nice. Blown up. It's going viral.
Take another minute or two.
So like, imagine you have the money translated separate columns, right? And so in ggplot, you can call in year and run those columns.
Oh, I was like,
right?
oh, okay.
particularly in length and weight of data to like just transform them.
I'm gonna be pass fails.
But if you the joining sort of aspect is sort of taking that tightly. So one measurement, the measurement column is literally a name, height, foot, or weight. So for each animal, you have one measurement column.
I've never thought of it.
Row for each observation for height, foot, or weight. So then when you plot that, it's measurement. So that's right. Sure. Yeah. Just to do it to how to gather. This is just. Oh yeah,
Okay. So, right, I guess I'm seeing from the top here that you all are liking the authentic tasks, right? Kind of working with data how we might actually see it. Is it fair to say that we can both like the authentic task and find it overwhelming simultaneously, right? So totally sympathetic to that. And I'm getting the sense from some of these sticking points that a lot of it's related to the mechanics of using R Markdown. So we're going to work in R Markdown today, and we're going to sort of go over some of those specific things, especially this one here. Is that seriously plus 22? All right. Yes, that is that's a true fact, right? It's the working directory works differently in an R Markdown document versus just the R scripts that we've been doing. So we will talk about that. Anything specific that you all want to go over with the homework? The links to Ryan's solution and my solution are on this Google Doc. They are in our repository.
Anybody look at those solutions?
Yeah.
Yeah, cool. Great. Did you, the one thing I was going to say, the beginning of, which we should show in our knitting, why don't you show your way of how you did your setting your directory, your working directory, and then I'll add the way I did it so we can sort of see the difference.
Did I set it in my example? What do you mean?
However you had it, where you use the dot in your actual thing.
Okay,
but
right.
I do it in the global settings where you actually make that the global.
Oh, cool. You'll have to point me to how to do that. I might be interested.
So we'll show both so you all can see that. So
sounds good.
That's one of my biggest frustrations with our Markdown too.
All right. Okay, let's start. So we're going to open up our studio. Oh shoot! This is the website, right? That's not us.
You can close
we'll do that.
To make it easier on ourselves.
We'll do that.
So can I ask a really basic question about
Always.
our studio?
About what?
On opening our studio.
Yes.
So when you open it, like when you go to your like programs and you open our studio, that's actually like subtly different from opening an R file or an R Markdown file that's like in a directory.
It
That
is.
you click and open, and then our studio opens it.
Yes.
Can you talk about that?
Yeah. And so the one going and opening the program directly doesn't do anything as far as setting the sort of working directory of the like where R thinks all of your files will be saved, right? And so I never open our studio like that anymore, right? Whenever I open our studio, I double click that .rproj file from wherever in my file directory that is, because that then sets that working directory and says, okay, every file that we're referring to, whether we're grabbing data from the data folder or writing data to the data output folder or making a figure or what have you, it's all these relative file paths. Does that make sense?
Yeah. So I guess my question now is like, what if we were to start on something that doesn't belong to an existing R project.
You just want like a script that's something that's just code.
Yeah, or say like whatever we do today, if you have us open like an R script or an R markdown document that you don't, like hypothetically wouldn't want us to keep in our learning tidyverse project. You know, did that?
Yeah. Well, so I'll answer it, and then if anybody else has thoughts too. I would say I wouldn't open up a script file unless it's within an R project.
Okay.
Right. So like what? And this is maybe just reflects how I've been working with my R projects. You know, since I learned how to use them and think that they're great. I go create a new R project and create that folder structure if I want to write a new R script or an R markdown document. Is that how everybody else over there would agree, or is it,
yeah, I would say if you, I pretty much would echo that. You only want to be in a project just because then you don't have to deal with, like, if you have data that you're calling or you're doing stuff with, you should be doing it in a project because otherwise you're gonna have to write code to set your directory and do all kinds of great stuff. And so just avoid that in general by just working in a project. Now that's not to say that you can't flip around that upper right-hand corner where it says R Davis Live Code. If Mike just clicks on that button there, you'll see there's a whole bunch of other projects I have, and I will often have, as you just saw, 2 or 3 open at once. And so, for example, I even have an R project called Test Projects, which is just sort of a playground of code, right? But it's all in one place. And so you use projects freely. You can always delete them. But the nice thing is it keeps it, again, in one place, and you can keep this whole sort of pipeline we're talking about together. So feel free to make another project that you can play with, but you should still be working within that. Because the problem is if you don't do that, suddenly you end up with scripts that sort of floating about that you don't know where they belong or where the data might be in reference to that. So yeah.
So we should be still in our learning type.
Yes, correct. We should all be in our learning type first project. Yeah.
I'll say that more explicitly. Yeah. Right. Don't just open our studio.
So then, if you're going to use like the same CSV for data for more than one project, we have multiple copies of that CSV in your data file in your project.
Yep.
And then in the project, you then have underneath it the files that would be data and output.
Exactly right.
But when I just click on the program RStudio and then I open a script, and that's the first thing that I do, it then default sets my working directory and takes me to the project that script is in, right?
It will always default to the last project you were in. So if we close this out and reopen it, it will open back right up to R Davis Live Code. Now, if you switch projects, it will then default to opening whatever your default project is. The other thing to bear in mind is if you are not in a project, so say I closed out of this and just opened RStudio, sort of a blank RStudio that was not part of a project, you can still open scripts and do all that stuff, and that's going to be wherever your default directory for RStudio is, which is in the global settings. You can actually set it to like wherever you want, but that's not necessarily going to be a project, right? It's just sort of does that make sense?
Yeah.
Ish. Ish. Okay. These are all really. This is, I think, really good to talk about because we're in week 8, right? We're talking about project management, but you will find that this often boils down to like you're learning the code and the pieces of the code, and you're going to get better and better as you go. But project management will keep coming back as you start dealing with other more complicated projects. So the more you can really force yourself to do these things, they sound simple, but you have to make it a habit, really. If you don't, you will end right back up to sort of this like loop of infinite coding that you don't want to be in. So really, really try to, like, you can tweak your pipeline, but just have something that's sort of contained like this.
Would you recommend going back and putting stuff like like taking the time to fix that all and putting it
With the caveat that like if that project is done, like there's always this balance of how much extra time to spend doing that versus doing new stuff. Like you're never
but if it's something that you're
absolutely working on it.
Yeah, I do. So anecdote, I did that for the project that I was working on recently. Just came back to it after 6 months. I was amazed at how readily I was able to sort of get right back in the groove of working with it. So I think it is worth that time if you're gonna continue working with it. Yeah.
It's also worth getting in the habit of just using like get WD or get your working directory, right? Know where you are. Just like getting used to some of the really base R tools that just tell you like, what am I doing right now? Where am I? Like just getting used to just going to your terminal, just going putting that in, figure out where you are, just like checking up on stuff like that. Because I can't tell you the number of times I've been very frustrated when something's like, you can't find, no such file exists. And I'm like, oh, it exists. And then I just was in the wrong working directory. It happens all the time. So just getting used to running those sort of little diagnostic tools just every once in a while you're working, I think it really helps you stay grounded in where you are, not just in a particular script.
Can you show where in the console window?
Yep.
So look at the top and then the gray right there. Does everybody see that? It's really tiny. I always check 100% of the time when you open a project, this is where you are. It will tell you right there, and even has a little, I think if you click on it, it goes to that folder, right? So and then it will suddenly like go there. Okay, so you can always check, even without code. I mean, so you're right, you can use these other commands, but that's one of the cool things about RStudio is if suddenly you open this up and you're just like, it stops at Dropbox, and you're like, oh, I'm not in a project anymore, or you look over here and there's no project, this will actually not have anything. It'll just say like RStudio or something like that. That means, all right, stop and figure out where I am, or I need to be in the right place. All right, sorry, derailed.
No, that's all super important stuff. Right, so I got to this particular script file by double-clicking the rproj file. So go ahead and do that for the Learning Tidyverse repository. I think this will be the last week that we're working with that, and then we'll create a new one next week. And what I want you to do is, this is my R Markdown that I'm going to work with today. The live link is still in the Google Doc, so it works just as before. I'm going to keep saving it. If you refresh that, it'll show you all the code for the RMD. And go ahead and go up to File, New File, oops, File, New File, R Markdown. And this is the dialog box I think that we saw last time also for creating a new R Markdown file. Go ahead and leave the default output format as HTML. You can fill in the title or author if you'd like. But essentially, that's how I got to this right here. And what I want you to do before we do anything else, I want you to knit this document and compile it all together. Make sure that everything's working how we think it is. So up here under the knit button, either knit to HTML or the keyboard shortcut on a Mac is Command-Shift-K. Okay, so does everybody have the knitted HTML document? Put your red sticky note up if you don't, and somebody will be around to help you out.
That's not I don't know what it is on a PC to knit.
So wait, say that one more time.
I'm not sure what the shortcut is to knit on a PC, but I don't.
It's not. Oh, okay.
I don't know.
Yeah. Does anybody have a PC that knows the keyboard shortcut?
I just clicked the knit button. I don't
All right, that sounds fine.
Control-Shift-K.
Control-Shift-K. There you go. Okay, so we're going to get in the habit of knitting our document very regularly, and we are going to work with this surveys data set. You know what? Let's change the title. Tidy R and joins. Oh, I just got that. R Davis. Nice.
Yeah, that's cute.
Okay, so I'm going to get rid of all of this, right? This is the default stuff. This is usually what I do when I open up a new R Markdown. I even tend to get rid of this also. So we're just leaving this YAML up here at the top, which are arguments to tell RStudio how to put this document together. And let's say to convert data from wide to long format. And vice versa. Okay, so let's knit that again. Make sure we're on the same page here, right? So I use the pound sign. Now when our markdown pound is telling me that this is going to be a header, so it's big. right? The title has changed, and that's just plain text that I've written in that document. So first we need to load our libraries. And to do that, we need to execute our code. And so to execute our code within our Markdown document, we insert a chunk. That's Command Option I on a Mac. PC people. Control Alt I. There's also this insert button up here, insert R chunk like that. Now something that we maybe didn't show you is you can name your R chunks. So this is saying, okay, we're gonna use the R language, a space after that, and I'm gonna call this load libraries. And let's go ahead and load the tidyverse. Knit it again. And just like this. Okay. I'm going to go ahead and add some of these arguments. I'm going to turn off the messages, and I'm going to turn off the warnings. So now when I knit this, it should be just that chunk of code and then nothing else, but it did run it. All right? Yeah?
Does the load libraries do anything besides inform you what you're doing? Or like the load underscore libraries?
No, good question. So let me show you over here in this R Markdown. Here's what happens when you knit the document. Starting here. So it's processing this file, and you can see that it's going to work through these different, the YAML, the text, the code itself, and now you can see this labeled code as it's working through that R chunk, which is actually called load library. So you get a better sense of maybe where things are breaking if they do that kind of thing. So it's a label for that chunk. Okay. Now let's get our data, and if you can go to the, I'm going to insert another chunk. Go to the Google Doc, and there are two CSV files. Right here. Go ahead and grab that second one, this portal data joined.csv. So copy that. And we're going to call it surveys. We've seen this before. And we're going to use our read underscore CSV file. And in quotes, we're going to put that website. So that's going to use the read CSV function to go grab that particular data set and then store it as a data frame called surveys. And what's the first thing that we do after we read in new data?
I'm pretty sure you have to load the tidyverse in your console rather than the R Markdown first in order to get tab complete for the read under -CSV.
Oh, because it's not.
So that you have to run the first chunks by itself, I think.
Okay, so that brings up a good point too, that as we knit this, R forgets everything that it's ever learned, everything that's in the environment. It starts from the very top of this document, and it only knows the things that are within this document and that work in this document, right? But we can also run our code directly from the R Markdown. So for instance, if I highlight this particular line and run that, now you see it sends it over here to my console, and we've loaded the libraries now, and we can work with them just as though we had run it from an R script file. So what Ross is saying is now we have access to our tab complete. So for instance, after I read data, I'm going to take a look at the data, and we should be able to use tab to say, okay, GL glimpse is one of the functions in dplyr that we've been using to look at these data. Let's knit that again.
Copied the .rb file.
Oh,
Yeah,
I grabbed the wrong one?
Yeah.
My bad.
Yeah, wait, someone messed up this code.
Oh, it's because there's a. It's been.
Oh my God.
Someone butchered it.
Someone butchered it. All right, tell you what. I'm going to, this should be the thing to copy. Everybody calm down. We can do this. I'm gonna paste this down. Somebody's Viva's on it. All right, hero status. Here we go. Let's try this again. So this should be a CSV file. All right. So now let's knit it.
You have the wide file, not the portal data join.
Again? Dang. All right. We'll get this right.
Can I ask another question?
Yeah, go for it.
So in the first code chunk, you had the message equals false, warning equals false. Does that only work in that first code chunk, or does it carry through the whole Markdown document?
Really good question. So those arguments are specific to that code chunk.
Okay.
And I believe, add this in. So that original. Thank you. So the original chunk that we deleted, there was something, it was called setup originally, and there was like a global options that you can set that would say, for every single one of these code chunks, say messages equals false or echo equals true or what have you. So there are ways to sort of reset the default arguments for those chunks. Yeah. All right, third time, right? That looks better. Just like this, right? Okay, so we've got 34,000 rows of 13 different variables. These are their names. And let's see what we want to do. Summarize them first. Here we go. All right, so what we're going to do is first summarize these data. And we're going to call it surveys GW. We're going to assign it surveys, and we will pipe that filter to remove the NAs in the weight column. I'm going to get the mean weight for each genus and plot ID combination, right? So I'm going to use that split, apply, combine strategy. I'm going to group by the genus first and the plot ID. Use summarize and name a new column called mean weight, and that's going to be the result of calling the mean function on weights. And since we've created a new variable, let's look and see what it looks like. Knit this again. So here's the operation that we just did. We took the surveys data frame, we filtered out all of the rows where weight was an NA. We grouped by genus and plot, and then for each genus plot combination, we took the mean of the weights, right? So we end up with this 196 different observations of 3 different variables. And I'm going to show you. So just to show you the sort of shape of this data, now I'm going to call the head function on surveys GW. And so this is what it looks like, right? There's a single column for genus, a single column for the different plot IDs, and now the mean weight across all of the different observations for each genus plot ID combination. So what happens if we want to reshape this data? Right now we've got these 3 different columns such that we have, let's say, a different genus in each column, right? I think there's a few different genera in there, and so we can shape them such that there's a different column for each of them. And to do that, we use the tidyr package, which was automatically loaded in tidyverse, and we use the spread function. Into wide format with the plot ID for each row and different genera across columns. So we're going to take surveys GW, and we're going to pipe that to the spread function. Spread is in the tidyverse, so the first argument it expects is the data. And the philosophy really here is that we need to think about what the key value pairs are, right? Where key describes the different variables, and then the value represents what the measurement is that's going to go in those different cells. So I want to show you this figure here.
Do we want to name this as a different object, or are we just?
Say what?
Do we want to like create a new object with this, or are we just looking at it?
Red stickies up if you have questions.
We can just look at it for now. We can change. We can add it. Okay, so here's a nice figure of what we're trying to do, right? Here's the data frame that we have with different plot IDs, different genera, and the different mean weights. What we want to do is transform it into this wider format where we've got a different row for each of the plot IDs, but now each of the genera is across in a different column with the mean weights as values within those cells, right? And so when I say the key value pair, what I mean is the key is the thing that's going to go then become the columns, and the value are going to be the measurements within each cell. So what that looks like is this. So we're going to spread. The first argument is the data, and we've piped it through. Next argument is the key, and that's going to be the genus, and then the value, genus. And then the value is the mean weight. So let's knit this and see what it looks like. Okay, so here's the data frame that we had before, 3 different columns, and it's in this sort of tidy format, right, where there's a different variable per column. And now we've spread it out such that each row represents a different plot ID, and now each column represents the different genera that used to be in the genus column, that were in the key column.
And we didn't do anything to plot ID, right? So it just got moved all the way to the left.
Yeah, so it sort of went along for the ride with the when you spread it, right? Yeah.
Is there a way to spread based on what you want the rows to be?
You want the rows.
Could you say like I want to spread such that every row is a plot ID, or do you have to say what that would be?
Isn't that so? That's sort of what we've done by not including plot ID within the key value pair. Or what?
Yeah, I guess I just meant like if you had something that was potentially like many more variables.
Right.
Is it easier to sometimes just say like, okay, I want every row to be this sort of observation? Can you do it that way?
Yes, you can get there, and it involves adding additional arguments to spread where you're including or not including particular columns. So we can get there. Yeah. I think, right.
Why do we get NAs?
Good question. So in this original data frame, let me pull it back up. If there's not a mean weight, if there's no individuals from this particular species or this particular genus in that plot, and it's calculating the mean of nothing there, then it's going to return an NA, right? That's like the default fill value if there's nothing to sort of spread out, is to, you know, maintain this square shape of a rectangular shape of the data, but then add in that desired fill value. But glad you asked.
We filtered all the NAs out of our original data set, right?
Correct. Yeah. So there's no right.
So we're only getting NAs if there's no entry for that pair of plot and genus.
Exactly right.
So even if there was one, then it would just calculate a mean that's the single value.
Yes.
Okay.
And we can change that behavior. By calling spread function with key equals genus, value equals mean weights, and telling it the fill value. Like, let's say that, I'm not talking about, let's say we want the mean weight to be 0 if there's not an observation for that particular plot ID genus pair. Now these all got zeros instead of NAs like they got before. So you can imagine if you were, say our summarization wasn't collapsing all of those weights into a single value. Let's say we were like counting number of individuals that were there. And if we didn't include any data for a particular genus in that plot, that count would show up as NA unless we say, no, I actually want you to put 0. Like, we did not observe any individuals for that particular genus there. So you can sort of adjust the fill depending on your use. Yeah.
So when you're working in R Markdown, are you never really running code? You're just knitting. I mean, that's the way you're looking at. Or is there a benefit to doing that rather than like running the code within R Markdown?
Yeah, and so yes, I'm knitting it because that tells R to forget everything that's in the working environment, and it just says, okay, you have to be able to run all of this with just what's contained in the chunks, right? And so often what I'll do, and I don't know if this is best practice, is to like still run some of this code as though it's R code and sort of test it out and sort of play with it in the console. But then when you knit it, that's the sort of real test of, okay, but does all of this actually work together, or was some of it maybe working because you defined some variable in the past that now is no longer present?
Makes sense.
Yeah.
And if you're doing that, one little tip is if you're working with a particular chunk, you can see there are 2 buttons in the top right of any given chunk. The left one it'll run, I guess the right one, yeah. Middle one will run all the chunks above it so that you can then play with stuff in that chunk and you know that everything is already done above it. And then you can mess with that chunk and play around and actually run stuff in the console as you'd like. But
that's a good point.
Yeah, that can be frustrating when you knit something and you're like, oh, it's all there, and then you're trying to mess with something in one chunk and it's like, the library's not there. And it's because you haven't run actually the chunks up above, just in the console.
Good point.
Up here, I flip back and forth too. I totally run stuff in chunks and then I'll knit. I kind of knit more strategically because sometimes it can take takes a few minutes or a few seconds. So I will do it like after I have a section where something has happened or I've done something. I feel like then I knit it to make sure that it will do that again. So yeah, but it's flexible. It's kind of up to you. Whatever works.
Just to point out too, up here under this run button, you can also run all the chunks above and below, or run all of them there too. And since we're on the issue, this is the spell checker for our Markdown, right? So it does exist. Okay, so now we want to convert from wide format back to long format. So let's surveys y. So I'm going to call a new data frame the result of surveys GW, piping that to the spread. Key is genus, value is mean weight, and let's keep that fill value at 0 for now. So now we've got this new, and here, let's do it right now. I'm going to, run all of them above that center button. And so now when I run this code, it should have saved that, the result of that to a new object. So I'm going to run that, and this is what we saw before in the knitted document, right? And so if we spread, if converting from long form to wide form is spreading the data, we use gather to go the other way. And so we can take this surveys wide, pipe it to gather, and drive this point home. When we're going the other way, we still think about key value pairs, right? So when we're spreading out, the key actually refers to a real column name in your data set, and the value actually refers to a real column name in your data set. When we're gathering, going from this wide form back to the long form, we have to think about what those key values are, right? So if we want to take these columns and put them, collapse all the wide columns into a single column, we have to think, what are these values, right? Well, we know that they're genera because that's the data that we've been working with. And then we have to think, what are these individual cells within the wide format? Well, I know that they're mean weights, so I'm going to make value the mean weight. I'll show you what I mean. So when we're gathering, we have to think about what the keys and values are. But when we're spreading, we get them directly from our data frame. So gather, now we're going to say the key is going to be genus, and the value is going to be mean weight. And now the difference here too is that we need to specify which columns we actually want to be collapsing. So you can do this in a couple of different ways. You can list out the actual names of the columns. We can B-A-I-O-N-Y-S. We can even use the colon operator, which we've seen to create a vector using the column names. And so the last one is S-P-E-R-M-O. This. Sure can.
Can you make it a little bigger too?
Sure
Realize
can.
that's- I didn't do that yet.
Big enough?
Yes.
And so let's knit this so we can look at it on a bigger screen. Okay, so now we've taken this wide format data up here with the different genera in each column, and we have gathered all of those columns by specifying the names of the columns here. I've used the colon to say I want to go all the way from this Biamese column all the way to the Spermophilus column. And I've specified that the key is going to be the genus. So all of those columns are going to get collapsed into a single column called genus. And all of the values are the mean weights, right? All of these values in these cells represent the mean weights for that particular plot ID genus combination. Yeah.
What is the key actually doing?
Okay, here and gather. So it's telling R what should I call all of these columns that you're collapsing into a single stacked column, right? And so in our case, because we know that each of those columns, like the column names themselves, are different genera, then we're saying that the key, the name of that column should be genus. That's the sort of word that defines what all of those different column names were.
So basically the new column name is genus.
Right.
And the values of that column are the different names.
Yes. Wait, say that last part again.
Like the character strings that are going to be in those cells for that column
Yes.
are the genus.
Yes. Right. So we've taken the column names from this wide format data frame, these column names here, and then we've added them as the values in that particular column. Right.
Is value here just another column? Because that we said key equals genus, value is mean weight, and then we go back and define the character strings or whatever for the genus column. That's a little interesting.
To say it again. So yes, we've said key is the genus, and we've taken all of those column names, and we say those represent the genus, right?
Yeah.
And then for the value.
And then value, mean weight just becomes the next column.
Yeah, because we're taking all of these individual values, like these actual measurements, and saying, okay, well, what do those values represent? And when we go to put these values here in their proper place with the plot ID genus combination, what should we call that column that contains those values?
And one other way to think about this is not easy, and I still have to Google this stuff when I end up doing gathers and spreads. So give yourself a little time to absorb this. I found if you think about the key, is particularly in gather as a group by, it's largely what it's doing, right? You're grouping by, and you're naming it genus, right? But so basically you're saying your key is going to be genus, but you're not actually telling it. Your group by is actually, it's basically grouping by these here, in a sense. You're telling it, look over these columns and make a group, a key here, and then the value is whatever is in these columns, and you can name it whatever you want there. I don't know if that helps, but just another way to think about it is you're sort of doing a group by that is then iterating over a set of columns that you choose, and it's up to you what you pick.
I'm going to show this too. You can also choose the columns here by saying, don't look at this particular column. So gather key equals, and here, tell you what, let's change this. This is going to be called the genus. Value is going to be called the mean weights. And now we're going to say, don't gather across the plot ID column. Instead, gather across every other column. And let's see if that does it. So now my column titles are the genus and the mean weight, because that's what I've specified for key and value, right? I've thought about what those particular column titles represented in the wide format data, and then what the particular values represented in that wide format data, and then did that group by operation. Right, so good question. So if we look at the wide form, remember that when we were gathering, the final argument was to say, okay, what are the columns that I want you to gather? And what I said was, okay, gather from biomyces or biomes all the way across, every single column. Notice that there's a few columns here that aren't actually printed. So spermophilus is the final column. So we are specifying which columns to gather by saying get all of those, right? Or we can say, with the minus sign on plot ID, say just gather everything else. Right, so that was a handy way of saying, well, I know I just don't want the plot ID gathered by every other column. Y'all want to try one?
It's different because it's actually group by sort of. This is a more flexible sort of way to rearrange your data, and group by is doing a similar thing, but it's doing it in a different way where it's iterating. What's the best way to do this? It's basically picking a given column or columns that you are then slicing your data by. This is sort of taking that and just taking, say, if you have multiple columns, squish them all into one value. And so, in a way, ggplot really likes long data. It doesn't do well with, which is because that tends to be the tidy data, right, where each column is each column is a unique variable, and each row is an observation. So when you think about that data is typically long in format. When we're looking at this, you know, the genus, if you have a genus, like each column is a different genus, that's not tidy, right? because you have the same type of data in multiple columns. You want it in one column. So that's why this is a really, but that's okay, because that data happens all the time. And sometimes you need to flip back and forth, but that's, I don't know.
Can you then create a column header on top? So now you just have the list, like varies onwards. You then add in,
like change your column names?
Yeah, like row 1, say species name.
Oh, sure, you can make the names whatever you want. Yeah, we can show that later if we have like, yeah.
Okay. Let's try it. So what I want you to do is take the original surveys data frame, not this surveys underscore GW one, but the original surveys data frame. Make this bigger too. No. And I want you to spread it with the year as the columns, the plot ID as the rows, and then instead of the mean weight, use the number of genera per plot per year as the value. So think about what summary you need to do in order to get that data before you can spread it. So take 5 minutes and do that. Green sticky note up. Okay. If you finished, and red sticky note up if you need a hand. So here it is here. Spread the surveys data frame with year as columns, plot ID as rows, number of genera per plot per year as the values, and you're going to need to summarize before you do that spreading.
If you have, when you're done, put a green sticky up, or if you have questions, throw a red sticky up. Or work with your neighbors too. This is not easy, so leverage your brain power. Yeah. So this was. There's a way to do it without the select. So making the involved value, then basically you can subtract out these two which is gathered by year, so that looks like that. Basically, yeah. So you can filter it out.
And then what?
Well, that's all right. And then the gathering for summarizing by these three things, adding a new value, and that looks like. This, so that's when you can add the new value, measurement for each hot type year. And then finally the spread, basically spread out. So,
Okay, so you would make a new.
yeah, I would say that is not super easy to do. So, I mean, you could show this part.
Yeah.
But that is potentially one you can select. To start, you can select the rows you're interested in doing on this quick, and then do a gather. This I would maybe pull up on unless you but maybe like this parcel. You could work together. It's up to all the other so yeah. Cool. It's 3 months.
Yeah, so it did.
I think it's
It does, but then remember. Oh, yeah, summarize and then equals and
So, yeah, so I get that. It's the same as tally.
So when
And
you're
it's
in-
ending.
Yes, I guess it's just say for all.
You know what, I was looking through.
Yeah.
Yeah.
Gather all the columns and stuff. Or tally it. You need to tally the values. Like each one, yeah, I think that. Yeah, that's for sure. That's true.
To be honest, this is pretty short.
Yeah. I'm just gonna run this and see what.
Yeah, some of these are things that I don't have to necessarily need each iteration to make sure that basically convert dates. You don't need to necessarily convert answers. Or, you know, it's something like that. But here I get to like that.
And then that gives me
Both dates, like dates and times.
And then
And this, and then beyond that, you know, the example. Let's see. Assignment involves this. This takes a lot of time.
Yeah.
Oh, wait, no, it says.
Right. Really what it's like.
Okay.
Oh, yeah, so,
You can put in
you
the.
could push off for like a full, like a properly. Because I do want to be worth doing. Yeah. Okay.
So, count that number.
Yeah, that's probably, I'd rather have time. I forgot the lessons. You could just sort of.
So I think we're saying, but it also. So we're gonna do.
Yeah, right, all of it, all, yeah.
Yeah, that's. No, it's. Oh,
Take another minute, see what you can do.
Because I did that indistinct, indistinct because I couldn't see how many pages. So this thing has a number of different things in this chunk.
So what I would do is here,
Oh, wait.
It's so sweet. You can customize it. See,
Really?
I've done.
Just under the help. I was trying to run. And I think because it's.
It makes sense.
Okay, let's come back up front. So I'm going to show you my solution. We're going to take a 5-minute break, and then we'll come back and do some date times. Sound good? And I want to double down on Ryan's sentiment here that spreading and gathering is really hard, right? Like these still trip up a lot of people that do it a lot. So don't be hard on yourselves. Let's see how this works. Okay, so the hint was that we need to do some summarization first. And to me, when I read this, I see number of genera per plot per year as kind of the key thing to be thinking about. So when I'm reading per, I'm thinking, okay, well, I should be grouping by those variables, right? Per plot and per year. So let's start there. We're going to take the original survey's data frame. We're going to pipe that to a group by, and we're going to group by year. Yep. What's that? By year, and I believe it was plot ID. And using that split apply combine strategy, we use the summarize function to apply some kind of function to those different groups that we've made. And somebody brought up on the Google Doc when we use tally versus the n and counts. Tally is a shorthand for summarizing for group by, and then summarize using that little n function. So they're doing the same thing. I like to say group by and summarize, and then say the name of the column. You can call it count. And then use this n function. Oh, wait, that's actually wrong for this particular case. Stand by. Let me make sure here. Right, use the function n distinct, right? Because we want the number of unique genera per plot, right? So we're going to call this unique genera count and distinct of genus, right? You. And so if we knit that, or actually we can just run it. What we end up with is this, right? With the year and the plot ID and, oh, I think we've hidden a column here. Might even need one more. So the year, the plot ID, and then the number of genera per year plot combination, right? So this is the summarized data frame that we're going to be working with, that we're going to try to spread. And let's see what this has to do. Spread the survey's data frame with year as columns, plot ID as rows, and the number of genera per plot per year as the values. Okay, so some of these are giving me some hints, right? The genera per plot per year are going to be the value. If we want the plot ID to stay rows, and then the year is going to be the columns, right? So that's the key, is what we want to take from our tidy data frame and then spread out to those different columns. So let's try that and see how it does. So pipe that to spread with key being the year, because we want to take the year, put it out across different columns. And the value is going to be, we called it unique genera count. And because there's only one other column, the plot ID, it's going to know to not include that one in the spreading. And so here's the result. So each row is a different plot ID. Now each column, because we said key was the year, it's going to be the different years. And then the values within this particular data frame are going to be the number of unique genera per plot ID year combination.
One extra question, why are there tick marks on the years column names? Why are they quoted like they're treating them as backticks? You're treating them as characters. Right, but why is that? I don't think we've talked about this. I just realized what I was looking at, so that's what I'm asking.
Because we ascribed it to column.
So
columns are always
this is that's
partly.
Both of those answers are correct in some ways. The problem is UR does not allow you to use a number to start a column name. So if you have a number, it will basically treat it as a character, like you're saying, because it can't. It's sort of against the rules, right? You can't start a column name with a number. You can include numbers after that, but you can't start one. So anytime, if you are bringing data in that has numbers in the column names, often you'll see it'll add an X, depending on how you import it, but it'll put a letter in front of each column name. So just for some of the things about it.
Okay, let's take a 5-minute break. Come back at 3:17, and we will pick up with dates and times.
Can you click back
To the code? Yeah. And it's saved, so it should show up on the live.
Yeah, all of these.
Yeah, right.
Yeah.
I love this
In that, you could assign your size based on whatever thing, right? So the bigger it is, the bigger the collar tree. But then you could also have the whiskers are essentially you have to make another column that's your minimum and maximum. But then you can assign those to shoot based on any given value. Maximum height or minimum height. Assign those so that essentially sort of little whiskers. You can make that different. Yeah, or this way. Yeah, that's my and then something else on top of that. There's also really there's an actual package. So maybe looking at plus custom icon like that. Yeah, but they have those. What's your Oh yeah. Yeah. So you read the CSV from
How's life been?
So they write to CSV. Because to read it using if, you have to do the dot. Right.
I'm just writing.
Yeah.
It's a learning process.
Other than that, is that a publisher? Publisher? Just like, but just a few buttons. Just a few quarter buttons. Your game is
Or like gauging how many yeah, I don't wear right. Yeah, totally.
Where are you at again?
I'm on Instagram.
Autopilot.
Yeah.
That happened back to back, so it was just like one day. That worked. Lots of identifiers. It's good. Sweet. Field work will be very soon. Look at those flowers.
All right, y'all. Let's rally back for a few minutes here. So I'm gonna show you two quick things using what we just have done, based along the lines of the sort of directory thing we've been talking about. Mike just showed me a cool new thing that I didn't know about in settings. But so remember when we opened a brand new R Markdown document? So you don't have to do this, but I'm just going to show you when we open a new R Markdown, and it's titled, I can't see. Okay. So it automatically puts in this chunk at the top, right? We've been just telling you to delete that chunk. What this does, it's called a setup chunk. You can name it whatever you want, but this is typically what it's named. And notice it has this flag include equals false. So did anybody play around with this? Does anybody use this? What do you think include equals false means?
Don't include that.
Don't include it, but where? And then knit. So do you think it runs it still? Like it evaluates it? Yeah. So include means include true or false means it will actually just it's still evaluating that chunk, but it's not going to show it at all. So include is sort of similar to echo equals. So include equals false is very similar to echo equals false, where echo is echoing your code, right? The difference is this: basically anything that is inside this code chunk is just, if you would do include equals false, won't show up at all. So even that includes like loading libraries and stuff. So if you did that kind of behind the scenes, this is another way to do that. But one of the things that you can do is you can set sort of your global settings for your R Markdown document. And that's what typically it's used for. So when you're setting this up, let's say, and typically this default is all your code chunks are echo equals true. So you're going to show all your code, right? If you want to change that, you can make it false. And then the nice thing is anything down there, you can specify for any given code chunk separately, you can change that. But the default, like if you don't include any of these little flags, will be echo equals true, or whatever you have set here. One other cool thing we can do, so I'm going to copy this over into our live document, so you'll be able to copy this in a second. So I'm going to save this so you have it. Okay. All right. So there's knitter is the package that's making all this happen right behind the scenes, and there's a whole bunch of options. So ops, chunk, $, and notice there's a whole bunch of things here that we can play with. There's also ops. Now I'm going to forget what the code is that I'm trying to show you all. Anyway, there's a zillion options.
not going to go into all of them. I think it's this. Try this, and then normalize path. Okay, I'm not expecting anybody to. So what I'm doing is setting something for the chunk, right? For knitter, and normalize path is a way. So remember the default where this document lives. Let's look really quick in my directory, because this could be different. We're storing all of our documents because these are being knit as documents in a docs folder. At least that's what this is, and hopefully most folks have that same setup. The problem is when we knit that document, it ends up in here in our docs, right? So if we look over here, there's some stuff, but down here at the bottom, you're gonna see week 8. It's not actually, do we knit it? Paths, oh, because I've added this chunk. All right, well, assuming that I didn't do that, you're seeing here's the HTML file, right? It's ending up in our docs. And so the other thing to think about is the computer is then only looking inside docs when it's trying to run things. And imagine if you want to access data that's outside of docs up in our data folder over here. This is what Mike was talking about, having to use a .. goes up a directory, right? So if we're in docs, inside there, and we're trying to access stuff, we actually have to go outside of that and go up to data. So .. to get up and back into our project directory. So in front of anything that we want to read in, if we don't use this thing, we have to add .. So before we dive back into this, let's show you. So let's take exactly what we just did here. Hang with me. I promise it's worth it. Dealing with directories and knitting. Okay, I'm going to make a chunk. Maybe, there we go. Make a CSV. So let's write a CSV using what we just made this. So let's take this whole thing here. And you can actually pipe this to write CSV. And so now I don't need to tell it what it's using what's being piped in there, but I do need to give it a path to data. And let's call this distinct genus by year, something like that, CSV. Okay. And then we're going to I'm going to just run this chunk by itself. And then make sure it worked. I'm going to go over to, I put it in data. Oh, well, that's fine. Distinct genus by year. Okay, so I have a file now. Cool? All right. So now, one other thing to make this work, I'm going to just cut this out for now. So it doesn't exist. I'll put it back in a second. In order for this to knit, it won't work otherwise. Let's try to knit this and see what happens. And actually, I'm going to delete this file. I just want to make sure it worked writing our code this way. Okay, so let's knit this. Has anybody done this? And yeah, there we go. Ah! Basically, it's the result. Why is that? Right delimited, blah, blah, blah. Cannot. So there's a whole bunch of stuff in here. Cannot open the connection, right? If I click on this little tab over here, output, quitting from lines 88 to 96, cannot error and open connection, cannot open the connection. So what do you think that means? Anybody guess? This is troubleshooting with R Markdown, so 101. This is, yeah.
It basically means that it doesn't see a file with that name, so it can't do anything.
Right. So if it's looking for this path, it can't go to this path. This path the computer can't see it. So, okay. So this is what I was talking about. Because it's knitting this inside the docs folder, it can't look outside of that unless we tell it to look outside of it. So right now it's actually looking for a data folder inside docs, which doesn't exist. If I want it to look outside where my actual data folder is, this is what we were talking about. This is where we want to add the .. That means go up a directory, then you'll find data, and then you go down into data. Okay? So now if we knit this, hopefully, it shouldn't break. Voila. Woohoo! Okay. Any questions on what I just showed you? No? Yeah, hands. Excellent. Yeah.
What if you, oh, sorry. What if you have to go back 2 folders?
2 folders. So let's say we wanted to, for whatever reason, we really buried our docs in docs. Sure. So you can add as many of these as you need as there are layers. So I could add another one just like that. One level. Yep, exactly. Aviv, do you have?
Okay, so mine was not so much a question, but I got around to that assignment by saving my .rmd just in my general projects folder.
Sure.
Is there a reason, and then I didn't have to deal with that, it just like did it normally? Is there a reason not to do that?
No, not specifically. So you could certainly keep all your. So what Aviv just described is she's keeping her RMDs just in her general project directory, right? So when she knits, everything goes down from there. You're in the root. The problem is when you start having lots of R markdowns, and especially if you get more complicated R markdowns that have figures and different pieces to them, it can get kind of cluttered. And because you'll have, each time you render it, you're creating an HTML file. And sometimes you're also creating additional little temporary files. And so then suddenly your nice clean project directory that has data, scripts, and whatever becomes less so. That's a total personal preference. We have sort of ascribed to this keeping your docs in your docs avenue, but you could certainly do that. So it's up to you. Yeah.
So does that normalized path function?
I'll get to, yeah. So I'm going to show you the shortcut so you don't have to, because now the problem is if I try to run this code chunk by itself, it's going to give me the same error. Why is that? I'm inside this code chunk and I just ran just the code chunk and it gave me an error. This is the one thing, if you learn anything about R Markdown, you get this, you're going to be way ahead of a lot of people.
Mine works.
Yours works?
Well, it works because you have the .. right?
Well, no. So if you're running this code chunk here, it's interpreting R is interpreting this as I am in my project directory, my root directory. So now it's actually looking outside, it's trying to go up outside of my project directory into a data folder, which doesn't exist. Does that make sense? So let's think about this. The R Markdown document is in docs, right? And it's trying to, whenever you knit it, that's wherever the R Markdown lives, that's where the base directory it's looking at. Your code, when you're just evaluating just the code, it is going to be wherever your project is. Does that make sense? It's a slight difference, but it's really important.
Wait, so if you're knitting versus running the code, is that what you're saying?
So mine worked exactly the opposite.
Okay.
When I didn't have .. it wouldn't do anything. Like it would only give me an error even if I only ran that.
Right.
And when I added .. then it was all good.
So there's also new defaults that I'm going to show you that made me switch.
I think I know why.
Okay.
I think if your default is document directory,
Right.
it'll work.
So let's all
You just changed it.
in is it preferences?
It's under the knitter.
Yeah,
It's just
Yeah.
like knit cancel and then knit directory.
So R Markdown. So I went to RStudio preferences, and down here, see where it says evaluate chunks in directory. So we're talking about our chunks, right? Our code chunks. It's evaluating. It's currently set to document, which is probably not. That's where the document lives. In this case, in the docs folder. So if you switch this to your project, suddenly you don't have this issue. Okay, so that's for evaluating code chunks in a directory. But it still doesn't get around the thing I'm going to show you in a second. I just want to show you, there's this setting, so you can do this. So if we do project, And then I do need to get on with our lesson. Okay. So I do knit. It's good. Oh, because I need to take this out now. So now when I ran this, it works either way. When I knit it, it should also work because it's evaluating code chunks. So we can set that under your preferences. Again, RStudio preferences.
Just go to the knit button.
And the knit has the option too. Yeah. So there's all these settings in here. So any questions on that? I just want to point that out when we're knitting. You know, yes. Do you have? Oh, Martha or Michael, can we got a red sticky here. Thanks. Okay, if you have more questions, we can talk about that in a little bit. The normalized path, which I was going to show you, is basically just a code chunk you can put at the top that will do that exactly what that preferences does. So let's ignore that for now. Actually, it's simpler this way.
What do you have to put inside the normalized path?
Oh yes, sorry. Let's actually show that. I apologize. So // So it's basically just saying normalize your path to go up a directory. So for everything you run, it's a sort of appending this to the path. Does that make sense? No? Okay, yeah, that's what I was gonna say. Let's not worry about this setup chunk for now. Because it's a little bit more complicated. All right, let's move on to dates and times. So dates and times. Okay. How many people, just show of hands, work with date and time data or are planning on working with date and time data? Yeah, sweet. Welcome to pain. I mean, welcome to, no. I'm hopefully going to show you a few kind of handy things that I've found to really make life easier working with date and times. So to start, let's just talk about, just to show you where I am or what I'm doing. I'm basically going to go through the lesson on course materials on the website and times and dates with LubraDate. There's all these wonderful package names. So LubraDate, there's some background info. I'm not going to go through that, but if you want to read a bit more, there's some nice info there. There's essentially 3 basic time classes in R. Okay, there's dates, which is strictly a date format. There's POSIX CT, which stands for calendar time, and that's, I would say, the standard and what we should all aim to be using. There's a slightly different one called local time, POSIX LT, which is structured much differently. And when I first learned R, that's actually what I had a lot of my stuff in, and I 100% advise you don't ever use that whenever possible. Convert out of it. Almost all packages nowadays will use the CT. So they will require, if you're working with some sort of time series data, LubraDate will automatically default to CT. You can use this other LT, this local time, for certain things, and it can be handy, but it's not as easy to work with. Okay. All right. So for a few, we've talked a little bit about at the beginning about data sheets and how they store dates in different, like Excel on a Mac. Their starting date is like 1904 or something like that, and on Windows it's 1920. It's the number of seconds since those years. So when you actually bring the data in, it can totally screw with your dates. So we pretty much always advocated that you split your columns up, right? Year, month, day. Because when we bring them in, we can paste those together, which I'll show you how to do, and make a nice clean date or date time column. But to start, let's just talk about dates. So before we throw time into the mix, let's use dates. So the date class is pretty nice. We can switch things around. So let's switch over to our live code. Just dates. Start. There's 3 time classes in R. Let's add those. So there's what was it was date, POSIX, ET. I'm adding these little ticks. You'll see in a second what happens when we render that. POSIX LT. Okay. All right. So I'm gonna go ahead and knit this just to see. You can see it really quick. Okay. Dealing with dates and times. Okay, so we made these nice little bullets, and it renders it as code essentially. So anything between these little backticks is code. Sorry, that's way down on the bottom. There. Can everybody see that? Okay. Let's go back to the code. Okay. So let's go ahead and make some dates. So make it add a code chunk. And we're gonna make a sample dates vector. Remember to make a concatenate, right? A list of things together. So here's the other thing. We need to, if I just type in a number, let's say 2018 02 or 02 25, and I try to send this into R, let's look at over here what I end up with. It says sample dates 1991. What? Why is that? Like if I run, so I've assigned this. Let's see what happened. Yeah. So it's just doing like order of operations, right? It's basically like, all right, sweet. Subtract 2 from 2018 and subtract 25 from that. Done. Okay. So dates have to be quoted all the time. Okay. So let's I'm going to comment this out and say need to quote the dates. Let's do this again. Now, one little trick, if you highlight something and then you hit shift and a quote, it will put quotes on both sides for you.
Can you say that again?
So if you, let me add this right in here. Insider tip. If you highlight some code or text and hit shift plus a quote, a single quote or a single, it will basically, so let's do it right here just to show you. It adds a quote to either side. If I wanted a single quote, you could do that too. I think it works for both.
Is that an R thing or
That is an
wide thing?
That is an R Studio thing. Yeah. Okay, great. So we have one date. Super. Let's add a few more in here just for, and I'm going to add 2 different years because I want to make sure we have a few different, a range of things. 02. Notice I'm using year, month, day to start. Okay. It tends to be the easiest to format. 3. 1 and 20. Okay. Great. So now I'm going to assign this. And now if I type sample dates, there we go. I have this list, a character list. Notice it's a character of dates. The problem is the computer doesn't know that they're dates. It just sees characters. So we have to translate them. So to do that, handily, there's a very nice function called asDate. So whoa, where's my mouse? There we go. Sorry, looking and not typing. Let's convert to date. Pull this as date. So the function is as dot. Remember, there's a whole bunch of as dot to convert things. So as dot date. So now if I just basically give it these sample dates and run that line, nothing happened. What? That wasn't helpful.
You can make that new date.
Yeah. Well, not even that. It basically is just seeing. It doesn't know what format those dates are in, right? You need to tell it a format. So in our case, we want to tell it that it's year, month, day, right? So remember, we need to write code that the computer can understand and we can read. So this won't work because no format of dates. As date, sample dates. Okay, I'm gonna hit tab here and see it has an option for format. Here's the fun part of learning these different things. I'm gonna show you, it has to be quoted. Remember, dates almost always have to be quoted for any of this. There's basically a shortcut for every single little piece of the dates. So a capital Y, so the percent is basically to say that this is a date. So it's kind of a shortcut. Capital Y is a 4-digit year. Lowercase y is a 2-digit year. Don't expect yourselves to know all these. So if we want to basically tell it the right format, it's going to look something like this. Notice I'm adding these, the exact structure of my dates. So I have hyphens. If I had ampersands in there, I would have to add ampersands in here. Does that make sense? So you need to make sure that it matches exactly when you're using this function. Okay, so let's send this. Let's assign it actually, so we have something formatted.
Brian, does it matter if the Y and D is capitalized or not?
It does, because Y, a capital Y means a 4-digit year, and a lowercase y means a 2-digit year. Yeah. Okay, so now we have sample dates formatted. I want everybody to look in your environment, your global environment over here. Notice what happened. So here's my original data set, sample dates, character. Notice that this now says date, format, and it has a nice clean format like that. So we've formatted our dates. Now we could use them when we're plotting. ggplot recognizes these as dates and will appropriately label your stuff, okay? So if we had a different, let's say we had a different date structure, I'm just going to show a quick example of this, and then I want to get to LubriDate for like the last 10 minutes here before we get too far. So let's say I have a date that's separated by slashes. Well, same thing. And notice that still year, it's a 4-digit year. It's hard to say if this is a month or a day, this is the fun part of this. And then month and day, but it's separated by slashes. If I send that along, it just prints it out. But another way to look at this is wrap it in class. It says date, okay? I know that it's worked. Similarly, like I said, if you just want a gibberish example, you could do the same thing where we just add, in between each of these, we actually add a letter. And as long as it matches over here, it will still work, okay? So imagine if you wanted to look up what your date format is, because sometimes maybe it's like a 3-digit, like a month, right? Like October, it says OCT. So how might we do that? Well, remember this little shortcut to look up help as question mark as date. Hit enter, and then look at the help file, and it tells me, all right, this is the stuff I need. And then there's a whole bunch of details. And if we keep scrolling and scrolling and scrolling, down somewhere in here, date for details of the date class. So that's actually what I should have looked at, is just date. Where is it? I want to look at the list of these things. Why can't I find that? Format date, maybe? Welcome to finding help in our locales. Somewhere, and we will try to find it and link to it in the Google Doc. If somebody can find it, that'd be great. Is the, oh, here we go. It's under, so right here, it says format as character string, specify, yada, yada, yada. The otherwise processing is by strip time, which is another thing. Here's the, this is the part I think that lists, okay, here's the shortcuts for everything. So if you want to know what, if you have a weird date, it pretty much has every option possible here listed out. So century, day of the month, you know, year day, month that's fully written out, decimal days, etc. That's all there, okay? So I'm gonna add this in the code. Actually, I'm not, I'm gonna add it right here. You're out of the code. Format over date. All right, so let's, I'm gonna skip the calculation bits. You get the point. Once it's in a date format, you can do all kinds of, you can operate on how many days, how many years. You can subtract these from one another, which is really handy. I don't wanna dwell on that too much right now. I do wanna get to the Luber date, if I can find the mouse. So let's go ahead and all, if you don't have the package Luber date, let's go ahead and go to Tools, Install Packages, and Lubridate. Install. I already have it, so I'm going to cancel this so nothing happens that I regret. But you can say yes. It's actually often defaults as part of tidyverse. You may already have it loaded. So if you get something like this, it means you already have it, probably. That's fine. Let's go ahead and load it in a chunk. Okay. All right. Okay. The nice thing about Lubridate is it basically takes a lot of the pain of trying to look up these crazy codes and adding this sort of the structure and makes it much simpler because it's very good at sort of taking that and doing that for you behind the scenes. So let's say we want to format our same, sorry, frogs, frog break. So let's take a look at Lubridate. So we have Lubridate. How would we format this exact same thing, the sample dates that we had using Lubridate? Well, Lubridate did. Here's the cool thing. It's in what format? It's year, month, day, right? Guess what? There's a function called year, month, day, and it's YMD, all lowercase. You'll notice when you type this in, it pops up with a bunch of other things. Guess what? If you have dates and times in various structures, hours, minutes, seconds, you can quickly grab your function, stick that. It has to be a character vector, but you just put that character vector inside your function, and it will format it for you. You can rearrange these. Say it was day, month, year, DMY. There's a function for pretty much any combination thereof. Okay? So let's try this now. Sample dates. Done, like that. Great. And if we look at sample dates, I'm going to look at the structure of this. You'll see date, format, ding, 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 ding. Cool? Pretty easy. There's a few more examples. Again, the nice thing about this is if I had different formats, so it intelligently guesses it doesn't care about the space between, like whatever character, if it's a space, a slash, a weird character, that's fine. as long as it knows that the order is the same across everything. It's year, month, day, or day, month, year, or month, day, year. It doesn't matter. So you don't need to tell it the weird slash or whatever. It will guess and do it for you. Does that make sense? Do you want an example? Ish? Nah, okay. So let's talk about times really quickly. I apologize.
Did we have to install LuberDate or not? Go back there.
If you basically went to install LuberDate, actually, I would just try this. Do library LuberDate first.
It had an error saying something about date being withheld or something, but it.
An error or a warning?
A warning.
Warning is okay. Error means it didn't work. Okay.
Does it just come up in your packages? Because I have
I think it's default loaded now as part of the tidyverse now. I'm debating whether it's worth diving into this right now or not, or if we want to hold off and not rush through this. So what do you think, Mike?
I think we can use the assignment. We're just going to use some of this.
Okay.
There's only 5 minutes, I guess.
Yeah, that's what I was kind of mulling over in my head. Okay, so I'm just going to show you on the website. So this lesson, so let's walk through the lesson that's on the website. And this is what we're going to do for our assignment too. So the code, pretty much all the code you're going to need largely is here already. You're going to have to tweak a few pieces. What I go through here is show you some examples of using date calculations, some stuff like this. So let's go to the LuberDate package. Okay, so LuberDate, here's the examples I was talking about where I'm using the same thing, year, month, day, and it recognizes, despite these changes in the separators, it can see that, okay? The other thing is that it can deal with the times really nicely. So POSIX CT basically includes time. Remember calendar time? And it basically will default to whatever your computer time is, your time zone. So you did the same thing here. Instead of as date, we use as POSIX CT. And append a time. It could be hours and minutes or hours, minutes, seconds. You end up with a nicely formatted time, date time. But notice we had to add this very painful, long sort of formatting here to tell it what you have, hours, minutes, seconds, date, month, year. When possible, avoid, sometimes you have to go to the default to tell it exactly what it is. I would say 95% of the time, you'll be able to use LuberDate to do this. And that's because as long as it's a consistent format across the whole column you're trying to convert, you can tell it year, month, day, underscore, and then whatever the format is, hours, minutes. You can give it a time zone. So you can specify, for most things, you can look up the time zone and tell it, and we'll automatically make a nice, clean date time for you, which is really, really handy. Okay? Any questions on that? I mean, you can read through this and try some of this code, but it's fairly straightforward. What I want to show you is the example that's part of what we're going to do for our assignment. So there's an example here working with time zones. Take a look at it. What I'd like us to look at is this. So I have pulled a really cool data set from the Mauna Loa CO2, the meteorological station. And it basically has data collected every minute of every year dating back to when they started, like in the 1950s or 60s. I just pulled one single year, but that one single year has 500,000 almost observations in it because it's one for every minute, okay? So what we're gonna do is you're gonna grab that data that's linked right here. Mike's gonna post the same thing. He'll post the assignment with all these instructions. But we're gonna use an RDA file. So it's already formatted for you, which is nice. So when you pull it in, it will already have the very lovely date times sorted. And then what you can do is essentially take a look, and it's like I said, it's a huge data set. But what we're going to have you do is summarize that and make a plot based on date times. So here's what I was talking about. This is the code. This is here on the website, so take a look. But this is what I was talking about, pasting together your year column, your month column, and your day column to make a single character vector, right? It's not formatted yet, but we've made a new column called date time here. And then you basically feed that into your LubriDate function. So we've made a new column called date time. We pasted everything together. Tell it year, month, day, hours, minutes, because that's the format. And it's in Honolulu time. And it takes 500,000 observations-ish, and it will probably run in about 2 seconds. It's amazingly fast. If you try to do this in the base functions, it actually takes a fair bit longer. LubriDate is much quicker, okay? So we're gonna take that, and then we're gonna assign some stuff where we want you to clean it up, which we've already done. Removing NAs, they have a weird format. Take something and calculate a mean temperature or maximum minimum temperature and make some plots. And I want to show you here are some example plots. You can take a look at these, get some ideas, but we'd love to see what you all can come up with. But this is really cool data set looking at temperature on a minute. So probably plotting minutes temperature is not useful, but if we want to aggregate it, which is often what we do, this is a good exercise to do that, okay? So take a minute and fill out the survey for class today, please, on the Google Doc. And if you have questions, we will try to spend a little more time maybe in the future. We're going to do joins next week. We didn't get to it today. And we'll spend a little more time maybe with some LubriDate date time stuff if folks have questions on that. Anything else? All right. Thank you all. Take a minute. Please also, if you haven't filled out the sort of end of class survey that Mike has mentioned, I think is it on the it's on last week's Google Doc. Please do that, because we're basically going to pick what our last few weeks are going to cover, which is crazy. We have 2 weeks left. Holy moly. It sounds like largely a lot of folks are really interested in mapping, so that might be a good one we can spend time with, but I know there's some other options there. So if you want to have a say, please put a vote in there and let us know what you think about what you'd like to do for the last week-ish, okay? Sweet, thank you all, hang in there. Another day. Fair.
Another chunk of code.
Mm-hmm.